So yesterday we worked on slope basically the easiest way we can, and that's just counting and putting in the numbers and doing some simple division. So what is slope equal to? Rise over run. So if we're given a graph like this beautiful thing right here, we have a line AB. All you do is you count out how tall it is and you count out how wide it is. So the run is 1, 2, 3, 4, 5, 6. That's your run. And your rise is 1, 2, 3. So your slope is just 3 divided by 6. Slope is equal to rise over run. We counted it was 6 as the run, 3 as the rise. Or 0.5, right, Matt? What are you saying? So your slope is equal to 0.5. We do run into a problem in that we're not always going to be given a beautiful graph that ends up so perfectly at intersections like that. Josh? So, what we're going to learn, Matthew. Right, but we might remember when we were giving graphs like P and Q as your values instead of numbers, so they're hypothetical points, stuff like that. So you won't be able to graph it, you won't be able to measure it, you won't be able to figure that out. And that's what we're going to learn today. The first thing you need to do is list the coordinates. Where is A? What are the coordinates of A, Aaron? It is actually 1, 8. You're bang on. So 1, 8. We went 1 over and 8 up to get to point A. Point B is 7, 11. Yeah. We went 7 over and 11 up. So we're going to figure out how to calculate slope using just those points. How could you figure out the rise without counting up? So just using the points that we figured out, how could we figure out the rise? Maya? The cross multiplying thing? Yeah. If we knew the slope, yeah, we could do that. But pretend we don't know the slope. Pretend all we know is these points. Matthew, you got an idea?
Since you do the distance in between.
Yeah, that's exactly what you would do. The distance in between the y values. So you're going to call one of these point A and point B. They've already labeled it out beautifully for us. You take the y value of your point B and you subtract the y value of your point A. So your rise is equal to YB minus YA, which is just equal to 11 minus 8, which is equal to 3, which is exactly what we counted out earlier. If that's how we figure out the rise, how do you think we figure out the run using just these points? Taylor. Yep, so now you're just doing the x values and subtracting them. There's something really important when you do this. Whichever value you put first, so we put 11 first, that's the point that always has to come first. So it has to be 7 minus 1. It has to be xb minus xa. You can't flip those around. We already chose b minus a. So you gotta again go b minus a. So the run is equal to xb minus xa. And that should be equal to 7 minus 1 equal to 6. Same thing that we counted out by hand. So that's a powerful tool. Now we can do graphs without actually having to take all the time of drawing it out. You can just do a quick calculation. So using our answers from CD, where this represents your rise and this represents your run, we can create a new formula. new formula would be what? What would rise be? What would slope now be equal to?
8, no, 3 over 6.
It would still be 3 over 6, but a step before that, we're trying to make a formula. It would be YB minus YA divided by XB minus XA. It's still rise over run, that's just a different way of saying rise and a different way of saying run. So your formula that you want to put in here would be slope is equal to YB minus YA divided by XB minus XA. That was 4 pi on my part. Because those just represent your rise and your run. And that'll work for any points that you're given. As long as it's a straight line and you know that they're going up in a straight line or down, that system will work. So no longer do you have to worry about drawing out and taking time to properly draw. It's XB minus XA. Yeah, no sweat. So YB minus YA, XB minus XA. Yep, I'm not going to switch yet. So if we calculated the slope using that formula, we would still get what, Joe? You said it earlier? Yeah, it's still 3 over 6, it's still 0.5. Same answer, different way of doing it. More effective way of doing it, especially when you're writing an exam and there's no graph laid out for you. Because the only way these graphs work is if you have exact precision. I remember yesterday some of you guys discovered that even the graphs on your book didn't have exact precision because the lines were big, right? Josh?
I would think your characters with exact precision because when you get to number 5, there's a bit more of the gap.
Yeah, there's always just a little bit off, right? Yeah. So calculate the slope of line segments CD and EF. We'll just do CD, just to go a little bit quicker. So, label one of these points as your first one and as your second one. We'll do this one as our first one. That'll come first. So, slope is equal to the y value of C minus the y value of D. Which means on the bottom you have to have it the same way but with x's. So it has to be xc minus xd. Has to always be the same order. You can't flip it. What's our x value of C? At point C, what is x? What's the x value at C, guys? 2. So that goes on the bottom there. What's the x value of D? 6. So on the bottom you have 2 minus 6. On the top, what's the y value of C?
5.
The y value of C is up here at 5. What's the y value of D? Time. The y value of D. Oh, Michael. 2, yeah. Beautiful. You put those calculations in. And what do you get? So 5 minus 2 is just 3. And 2 minus 6 is negative 4. So your slope is up. Negative 3 over 4. You could do 3 over negative 4 or negative 3 over 4 as long as it's negative, right? Yeah, so you're right. We wrote it out as 3 over negative 4 because we did our rise as negative. And that makes sense for an answer, doesn't it? It's going down, so it's negative. Any questions on how we do slope like that? All right, let's take a look at some questions.
Do it like that, or can I just do it the graphing way?
The graphing, yeah. So
So much easier.
the graphing way is so much easier when you have a graph, right? The problem is you're not always going to have a graph. And then when you don't always have a graph, it's really hard to draw it out perfectly. That's the only problem. If you can always draw it out, it's more time consuming, and that's okay. You're going to get the right answer. So as long as you get the right answer, I'm happy. So we use the letter M to represent slope. So you don't always have to write out slope is equal to. Find the slope of a line which passes through these 2 points without drawing it out. How do you do it? What goes on the top? How do we figure out the rise? How do you think we figure out the rise? Joe, give us a shot.
The y, and then the other one.
Yep, it's the y
8 minus 2.
8 minus 2. 8 minus, it's a negative 2, right? Yeah. So you took one y value and you subtracted the other one. If you chose 8 to go first, that means on the run, what number do you have to choose to go first?
8, 3.
It has to be negative 3. It has to be the same one from the same point. What's up, Aaron?
On this one, does it say YH minus
It does. It says YH minus YG. Let's see if it makes a difference. That's a good question. So we went 8 minus negative 2. And now we have to use the same point, so we choose negative 3 minus 7. What does that get us? On the top, it should get you 10. On the bottom, it should get you negative 10. What's 10 divided by 10?
1.
Right, so the answer is negative 1. Okay, let's do it the other way. That's all it changes. So we did it the other way. So Aaron's already done it the other way. He did h minus g, and he got negative 10 on top over 10.
Still the same.
Still equal to negative 1. So it's the same way. As long as you pick one point to go first and one point to go second, you'll get it right. It's when you flip-flop that you get in trouble.
So it's kind of, doesn't matter actually. I know.
Yeah. If you chose G to go first on the top, it's got to go first on the bottom. Michael.
On the final answer, can you put the negative at the bottom?
Yep, it could be the negative could be on the bottom or the top. Doesn't make a difference. You're good. Down here, we've got some brutally named children. Eleanor, Bonnie, and Carl.
Oh, Bonnie and Carl.
Hey, there's lots of people named Bonnie. Carl the Cactus, yeah, earlier. Okay, Eleanor, Bonnie, and Earl. No, Carl.
Oh, this shit.
They all tried to calculate these 2 points. Well, we need to figure out who screwed up, or if anybody screwed up. So, let's start with Eleanor. She took the x value of her 10. She took her x value of f, and she subtracted the x value of 15. Are we good? Why aren't we good? Yeah, the x is on top. X's calculate your run.
All those done for.
So Eleanor screwed up right off the bat. She reversed her rise and run. Y goes on top, X's go on the bottom. You need to turn, face forward, stop looking at him. That one.
Oh.
There you go, good. Bonnie. She started off a little bit better. She chose her y values to go on top. So she took 6 and she subtracted 8. Are we good still? Yeah, she hasn't screwed up yet. Let's see if she screws up here. She takes 15 and she subtracts -10. So she chose x values. Are we happy? Why aren't we happy, Hannah?
You're like switched over.
She flipped them. So since on the top she chose f minus e, on the bottom she has to choose f minus e. So she's got to reverse these two. So she screwed up too. Let's see what Carl did. Carl went 8 minus 6. On the bottom he goes 15 minus 10, and Aiden says that's good.
No.
Now you're gonna flip it.
You gotta add negative. The other mine's negative.
Ooh, yeah, I was on board with you. I was like, he did do it right. It's -10. This -10. So they all done good. Every one of them. Yeah. So they all made simple, common mistakes, right? So when you look back at your notes, this is a way of looking at it and going, those are 3 easy mistakes that I'm probably going to make. Don't make them. Don't be an Eleanor.
I know who's gonna
Don't be a Carl.
I know a Carl too. The only person I don't know is a Bonnie. Bonnie's a loser.
Okay. Last example, guys. Last example, and then you guys can work on your practice booklet. We've got some different types of points here. We've got some points that kind of have a little joint in the middle.
I nearly died. Something.
We've got parallel points, like these ones. And we've got parallel lines that just connect and go all the way through. What do you think the slopes of parallel points are, Josh? They're the exact same. So parallel points are going up at the exact same. So if the slope of DE is 2, then the slope of FG is 2. What do we think about this one on an angle? It's 2 different slopes. Which slope's steeper? BC would be steeper. And they're definitely not equal because you can just visually see that they're not. They're going off in different directions, correct? We're not talking about today, but perpendicular lines are lines that hit each other right at a 90 degrees. What do you think the slopes of those are? So if you got a line like this, and you got a line like this,
No.
it can't be the same.
Opposite?
So you think it's just the negative version of it?
Indeed, I do.
The negative reciprocal of it? Ever heard of that term? That's something you guys will see in the future.
I can see it in the future.
You will be able to see in the future one day.
Well,
Okay, Let's consider points A, B, and C. Prove that they're collinear.
He wasn't about to right. That's it.
How do you prove that they're collinear points? Collinear. So they're connected. They're in the same line, right? Hello. Got it. So, how can you guys prove that? How can you prove that they're somehow connected? No.
Because they're running they're pretty much opposite.
They're opposites?
Oh wait, are they still on?
We're on this one right here. You're going to have to figure out the slopes in between these lines, right? So the slope from A to B and then the slope from B to C.
So, when we kind of do like the line which is straight across.
Yeah, that's what you're
So
saying.
maybe like the 0 and then whatever it goes.
I think I picture what you're saying. I think that'll work. What's the slope from A to B? On the top, you're going -3 minus 6. That'll give you your rise, right? On the bottom, you're going 5 minus 2. You have to choose the same points. And the slope there is -9 over 3, which is just -3. What's the slope from B to C? You got 2 minus -7, and you've got 6 minus 33. On the top, you should have, oh,
The Y should go.
so we flipped them? That would have been run over rise, which is no good, right, Ella? So let's try again. 6 minus 33 on the top. Better? Yeah. On the bottom, you got 2 minus -7. So on the top, you got 27. -27. And the bottom, you got 9, which happens to be -3. So those points are all along the same line, since they all have the same slope connecting them.
So it's simple, right?
So they're collinear. Yes, ma'am.
They all have the same what?
They all have the same slope, right? So the slope from A to B was -3. So we went from A to B. And then we went from B and we got to C by following the same slope. So since they had the same slope connecting them all, they're collinear. Because they must be able to all be connected this way. Yeah, that's why I said this way.
And another way to do it is make them into like this is the one that we can make them collinear calculator.
You could try that, yeah, and see if it would hit it. That would work. And that is a different way of doing it. If you're good at that, then that works just as well. Ella? Yep, that would also work. So if you drew a line in between A and C, and you saw that 2, 6 was right on that line, it would also work. All different ways of doing it. All based on the same idea that it hits the same slope. Yeah, like whatever method works best for you. Yeah, this method is foolproof.
Yeah.
So you don't have to worry about drawing it and drawing it properly.
Yeah.
Yeah, exactly, right? They're all multiples of the same thing. This is where it gets a little harder. Part B. Find the value of y for point D if it lies on that line A to C. How can we do that? That's a tough one, right? So there's some options. Option 1, you could draw it out. So if you already drew it out, perfect. You can just look, oh, -4, the y value is this. But that's probably not going to be exact unless you're really good at drawing those lines. A mathematical way of getting it exact is write out your slope formula and just use y as your y value, and then solve for that y value. So I'm going to do this question because I lost my expand page. I'm going to do it up here. No, yeah, I'll do it up here. So we're picking point A. We know that if point D is going to be on this line, then the slope from A to D has to be what? -3. It has to be the same slope if it's going to be on that line. So we can go point A. We're going to do the y values first. -3 minus, what's the y value of D? We don't know, so we call it y. We're dividing that by the x value for A is 5. What's the x value for D? -4. We do know. So here.
I got that wrong.
If that point is going to lie on that same line, this slope has to equal -3. If it doesn't, then it doesn't work out. So we need to figure out a y that would make sense there. On the bottom, that's going to turn into, so the top is -3 minus y. On the bottom, we should have 9. And it's all equal to -3. Whoa. Does that make sense, Ellen? Have I lost you? No? Okay. You're going to multiply that 9 up. So now you have -3 minus y is equal to -27. So 9 times -3 gave me -27. And now the 9 is no longer on the left side. We can switch spots. We're going to move that -y over there, the -27 over here. And we're going to have 27 minus 3 is equal to y, which just means y is equal to 24. And that is what your y value has to equal. You could have drawn it out, and you could have got it and figured it out. You could also do it by hand this way. Either way is fine, as long as you show some of that work. Any questions on that? Yeah, Emma.
So over there it was -3y, or -3 minus y was equal to -27, and you just did +27 minus 3y.
So what I did was I took my -y,
Yeah.
and I moved it to the other side, and I took my -27 and I moved it to the other side.
Oh.
Because negative y isn't what we wanted, right? We wanted positive y. So I had to move it to the other side by adding it to both sides. And I had to get my 27 to the other side. So I just basically swapped spots and made them both positive.
Oh.
But the 27 came from 9 times -3. So I multiplied that 9 up. Got a question? No? Josh? No. Yeah, and you're going to work it again today. Any other questions?